Hello friends, so today we will discuss the differential protection of alternator, which is also called merge price circulating current scheme. In this video we will talk how the alternator's winding being protected. We will see its basic principle, construction, working and limitation. So first of all we will see its basic principle. In differential protection of alternator, CTs should be connected on either side of the alternator. So, under normal condition, when there is no fault, the current which is going to be entered in the relay coil will be normal. So, the relay will not operate. Once the fault occurs at any point, then the current is not balanced current flow through the relay. As a result, this differential current will operate the relay. Since the current is going to circulate inside, so this method is also called merge price circulating current scheme. Now let us see its construction. In three phase of winding R, Y, B that we see in the circuit diagram, connect CTs from both the end in each phase. In this case, we connected star connected CTs on both the side, and both the star end are grounded at a same point, that is neutral. Now CTs are connected through a pilot cable, and from the center point of each phase the CTs are connected through a pilot cable, and through the pilot cable the three operating coil of the relay, that is R1, R2 and R3 is connected. In order to pertaining earth fault, high earth fault resistance ER is connected to limit the current, and in this we use three trips circuit that is provided in each phase through the relay coil. The differential current is passed through the relay because of the pilot cable which is connected to a center point of the relay. We connect the pilot cable at equipotential point. Now let us see its working. When earth fault occurs on any phase, suppose in R phase, in that case current is passed through the earthing resistance and it is grounded. In that case it is result into a unbalanced current in relay coil. The current is passed through the relay through a pilot cable. This differential current is deducted by the relay coil, that is R1, and if the earth fault occurs on any phase, then the relay coil will operate and trip the circuit. Next condition is a phase fault occurs between the two phases. Suppose the short circuit is occurs between the Y and B phase. In that case, the current is circulate in Y phase and B phase winding, because of which the relay R2 and R3 is going to operate and trip the circuit. The relay which we use as electromagnetic type or instantaneous relay, because if the fault occurs on the alternator, so in this case it should immediately act upon. So we will use electromagnetic type and instantaneous type relay. Now let us see its limitation. When earth fault occurs near the neutral, then it is observed that we cannot give 100% protection of the stator winding of the alternator, because if a fault occurs near the neutral, then the magnitude of the current is very high. So it is going to develop insufficient voltage across the short circuit portion, because of which immediately you have not having enough voltage to operate the relay. So only we can protect 80 to 85% of the winding, and the remaining 20% of the winding remains unprotected. So the basic limitation is that by differential protection we can only protect 80 to 85% of the winding, and the remaining 20% of the winding near the neutral cannot protect it. It cannot cause tripping. So the basic working principle is that in differential protection, that is merge price circulating current scheme, it should protect the alternator by earth fault and phase to phase fault, but its limitation is that only 80 to 85% of the winding is protected. The remaining 20% of the winding near the neutral cannot causes protected, it is unprotected. So in this video we see its differential protection of alternator. I hope you understood well. Thank you.